Everyone, another evening, another Wednesday. How are you? It's Irada from Brushand Chemistry again. I'm very excited. This is our first masterclass this year, this new academic session. So I am extremely excited to be here with you again. Now, if you are here for the first time, which means you have never met me, my name is Irada, and I am the founder of Brushand Chemistry. We specialize in supporting students to achieve an A-star in A-level chemistry. A little bit about me, I was a retired chemist, retired as a research chemist, went into teaching, have been in education either as a lecturer, as a teacher for over 30 years. During my time as a teacher, I was head of Department of Chemistry in 2 grammar schools in Kent and head of science in 1. I have had the pleasure of teaching chemistry for well over 10,000 students across the globe, and their results have always improved. In fact, the A-star to B grades in one of my schools, my second school where I was head of chemistry, improved from 17% before my arrival to 67% with my first cohort. Now, I am very excited to help students online to achieve an A or an A-star preferably at A-level chemistry, and thereby secure admission into top universities to study esteemed courses like medicine, surgery, veterinary surgery, dentistry, chemical engineering, and many other related courses. So I want you to know you are in safe hands. Today, my masterclass is titled How to Answer A-Level Chemistry Exam Questions. Now, I chose this topic because many Year 13 students will be taking some form of assessment in September this month so that their classroom teachers can accurately predict a grade A for them, so that at the end of Year 13, they will be assured that the student will get an A-star. And because of the way the results have gone this year, August has been a very busy month with a lot of crash programs, just to make sure, parents trying to make sure that their children do get this prediction of an A. It was so good this year, and I'm really excited about especially one of my students who worked with me personally every day for 10 days, 10 days. And he went straight from a D grade to an A in 10 days. His baseline assessment was a D. And 10 days later, he was averaging A, getting 91%. And I gave him a holiday for 1 day, of course, because I'm just that kind, you know. So let's dive in. I'm going to be sharing my screen. The paper I've chosen to use for this session today is my first real assessment for my Year 12s. So that is what I call my assessment hour. And that is when I teach them about what to pay attention to, so that they do not lose marks for what they know, what they haven't put down on paper. So without further ado, here we go. I am sharing my screen now. So this is my first assessment hour paper. Every question here is a past exam question, A-level question. So first question says, N2O3 reacts with water to form an acid as the only product. Notice I have put the only product in bold and also underlined it, because that is the key information that you must pay attention to. It's reacting with N2O3 and with water. The whole idea of putting this water in words and putting that in formula is to get you to think seriously. We know that water is H2O. And if you are going to get only one product, you can work out easily what that product is going to be. It's going to be N2O3 plus H2O. The question goes further to say, this reaction is not, notice, not is in bold, a redox reaction. The empirical formula of the acid formed is the same as the molecular formula. Those are important terms that you must know. Molecular formula, empirical formula. You must have them at your fingertips so that if I wake you up at 2 a.m. from deep slumber, what does empirical formula mean? You just blabber it out for me. What does molecular formula mean? You just tell me and you earn the 1 mark. So for 1 mark, there are specific things you must say. Is the actual number of atoms. What atoms? Atoms of each element that is present in the molecule. For instance, this compound, N2O3, contains 2 atoms of nitrogen and 3 atoms of oxygen. It doesn't just contain atoms of nitrogen and oxygen. It is specific, the actual number. Okay? Now, if you just say it is the number of atoms in a molecule, the answer to that would just be 5. 2 plus 3 is 5. It doesn't tell us what the elements actually are. Okay, now the examiner's report, I'm going to just share that in a minute. I'm going to stop this so that you can see what we pay attention to. Year 13 students watching me today, I need you to pay attention to this because you are going to need it in your UCAS prediction assessment, okay? So let me just stop this and show you the mark scheme. Share that, and here we go. Okay, so it says actual number of atoms of each element present in a molecule. That's what you need to get your mark. What is in brackets, you don't lose marks if you don't say it. But if you say it, you just make it easier for the examiner to really know that you know what you are talking about. Now, on this side, we have what we call guidance. In other words, there are some answers that students may give and we'll say, yes, I think this student is actually saying what we want them to say, and we allow it. And there are other ones that we will just ignore. For instance, if you are talking about whole number, when you have to describe molecular formula, that tells me you don't know the difference between empirical formula and molecular formula. And therefore, see, the exam board has said ignore it. So you get no mark for saying that. Actual ratio, because that is you actually saying the example that we use, the ratio of nitrogen to oxygen is 2 to 3, but you must mention the elements, okay? Now, the examiners, when this paper came out, when this question came out, yeah, examiners' comment was that many candidates were successful in describing the term molecular formula. Those were the stronger, more able candidates. But weaker candidates gave answers that confused terms, such as atoms and molecules. An atom cannot have a molecular formula. An atom will usually just have, except for very few elements, the grade 7, most atoms exist as monoatomic elements. So Na, for instance, will just be Na. Yeah, the grade 7, the diatomic molecules, those are the only elements that can occur as molecules. Yeah, for instance, oxygen. Oxygen is O2, nitrogen is N2, and so on. Yeah, so by a long short, most elements are not molecules except the grade 7. So when you are confusing molecules with atoms, while describing molecular formula, it tells the examiner that you really do not know the difference between an atom and a molecule, and therefore you will not be getting that mark. However, the examiners now went on to say, by far, the most common erroneous response was the number of atoms in the molecule. Number of atoms in the molecule, like I said, is just the total number. In water, for instance, you have 2 atoms of hydrogen, 1 atom of oxygen. And therefore, the total number of atoms in water is just 3. It does not tell you anything about the atoms that are present. Okay, so chemistry is quite demanding. It is challenging because it pays attention to minutest details. And that is what we want to equip you with, so that when you read a question, you can pay attention, look for what the minutest details are. Okay, so let's just go back to the my question. So this question, right? So we've answered that. For 1 mark, you say the actual number of atoms of each element present in that molecule. That's the molecular formula. Suggest the empirical formula of the acid formed. Look, it does say the empirical formula of the acid formed is the same as the molecular formula. And you have been told here, you have N2O3 reacting with water, which is H2O. And therefore, the formula of your acid is going to be H2 from the water, N2, but O is going to be 4. So you are going to get, let's just write something in a minute, quickly, on the whiteboard, so that you can get it properly, because I do not want you to lose any marks for what you know and what you haven't put down on paper. We will lose marks for what we do not know. Okay, so very quickly, this is what we were told. That's the molecule we started with, N2O3. Okay, and that is going to react with water, H2O. And it says no other product is formed. In other words, everything here will be put together in one product. So hydrogen first, because that is what makes it an acid. So we just put that. N2 is going to be next. Yeah. And the oxygen now is going to be 3 oxygen plus 1 oxygen. So oxygen is going to be 4. Okay. Now the question asks for the empirical formula. Yeah. Empirical formula is the simplest whole number ratio. So that is another way of finding out if you can define empirical formula. Simplest number here is 2. Divide everything by 2, you will get H, you will get N, and you will get O what? O2. Fabulous. That is the answer. Okay, so let's look at, let's look at what the mark scheme says. Okay, so this is what the mark scheme is saying. Is HNO2, of course. Yeah, the examiner has said, or in fact, let me tell you about the examiner's comments. So at the end of the marking season, every examiner has to make comments about the questions that most children struggled with, or the commonest error that the children had with the questions, or the questions that the children found really easy, or the common answers that they got right. So you have to just do that as an examiner every year. Okay, I usually just make notes as I'm marking, so that at the end of the exercise, it's easy for me to just send off my examiner's comments. Okay, now what the exam board now does is to compile all the comments from all the examiners and then choose the strongest ones. So for instance, if out of 100 examiners, 90 said, oh, the weaker students convince themselves that the acid formed when water is added to nitrogen dioxide with HNO3, that will be included in what the examiner's comment will be when it is released to schools. Okay, so it's not all, but it does give you a good indication of where the errors are, what errors previous students have made, so that you don't make that mistake. Okay, so this is what we go through with our year 12s. Okay, so most students know about nitric acid because right from year 7, you would have learned about nitric acid, sulfuric acid, and hydrochloric acid. So most students just gave HNO3 without bothering to work it out. That is chemistry for you. You cannot assume anything. You must show your working, work it out quietly, slowly, with all concentration. And whatever you get, that is what you put down. If you make a mistake in the steps, it is okay. You only lose mark for that step that you made a mistake in. Everything else is still fine. So the examiner's comment goes further to say, better candidates, which means more able candidates, were able to work out that the product will have the formula this, that, but failed to convert this to the simplest form. The question specifically said, give the empirical formula. See, suggest the empirical formula. Now, some of you will say, but they are confusing us. It's okay, look, it says here, the empirical formula of the acid formed is the same as the molecular formula. So some of you will say that is a confusion, because if they are the same, why are they asking me for the empirical formula? Empirical formula is simply the smallest whole number ratio of the atoms present. So you cannot, under any circumstance, give H2N2O4 as the empirical formula, because it is not the simplest whole number ratio. Okay? So the next one I want to talk about is this. You notice it's all about empirical formula. This paper, being the very first one, is mainly about empirical formula, water of crystallization, and so on. Yeah, so it's just physical chemistry. So we have a compound of thulium, atomic number 69, has the following composition by mass. State what is meant by empirical formula. By now, haven't learned about empirical formula from question 1, that should be pretty easy. But now you are looking at percentage. The common error that students make, this is talking about percentage, and they are thinking of only the mass. What am I going to? Percentage or mass, virtually the same thing. The percentage gives you the ratio of, say, oxygen in this compound, the ratio of sulfur in the compound that contains all 3. So you just do it exactly like you do your mass. You divide each percentage by the atomic mass. So that is divided by 16, or what is on the periodic table that you are given. A-level chemistry can go up to 2, 3, or even 4 decimal places. You must use what is on the periodic table that you have been given. Okay, so you divide by the atomic mass, and then you get your ratio, and you divide the ratio by the smallest one. So this is what we are talking about. We won't be defining anymore because we've already done that. So oxygen, you divide it by 16.0, being what was given on the periodic table. Sulfur, 15.4, which is the percentage. You divide it by 32.1, which is the atomic mass of sulfur on the given periodic table. And thulium is 53.9. That is the percentage. You divide it by the atomic mass. And you end up with a ratio of 1.92 moles for that, and 0.480 moles for that, and 0.319 moles for that. Looking at this, you can see this is the smallest number of moles out of the 3. Okay, so you divide this by 0.31, divide this by the same 0.31, divide this by 0.319. 1. This is an interesting one. A lot of children would have seen something like 1 there, and 1.5 there, and 6 there. And because that is 1.5, many students just assume that it is 2. It is not 2. Simplest whole number ratio demands that you multiply everything through until you get whole number, at least as close to whole numbers for all of them. So if this is 1 and that is 1.5 and that is 6, you multiply everything through by 2, which means that is going to be 2. This 1.5 times 2 is going to be 3. And this 6 times 2 is going to be 12. Okay, so that is how this formula came about. But not all students remember that 1.5 is not equal to 2 when you are working out empirical formula. Yeah, indeed, 1.33 or 0.33 is not equal to 1. A lot of students make mistake like that, like when they are working, trying to find the empirical formula of an iron oxide, for instance. Yeah, so if you work out your ratio and you are ending up with 1 to 0.33, you multiply the 0.33 by 3, multiply the other one by 3, and you will end up with proper numbers as in 4 and 3. Okay, so examiner's comments here. It says, this question perhaps demonstrates the extent to which candidates rely upon the rote application of a mathematical method without fully understanding what they are actually attempting to do. It's important that you understand exactly what you are attempting to do. Nearly all candidates were able to convert a ratio by mass to a ratio by moles of atoms. So go from the given value into your moles, okay? And they did that by just dividing the mass ratios by the relative atomic masses like we just did. These candidates were further able to obtain a unit value for one atom by the mathematical operation of dividing all values by the smallest number, which is what we did here. This was the smallest out of all the moles. We divided each one by the smallest so that we can get the smallest whole number ratio. So this gave a formula of TM S 1.5 and O6, just what I said. And many candidates were convinced that increasing the number of S atoms from 1.5 to 2, the nearest whole number ratio, was the right thing. They thought it would meet the requirements that an empirical formula has to have whole number values of atoms. Only the strongest candidates were able to realize, fabulous, that the initial ratio calculated needed to be doubled to obtain integral values which kept the same ratios of atoms. As soon as you assume that 1.5 is equal to 2 when calculating an empirical formula, you have modeled up the simplest whole number ratios. Okay, so that is what we have time for today. What I want you to take away as some of you start your UCAS assessment for your predictions to be right, I need you to calm down when you get into the hall or wherever you are taking the exam. You can do this. You are well equipped. Many of you have worked with me this past 1 month, and I have 100% faith in your abilities. So please do not doubt yourself, okay? Take your time. Start with the ones you know first. Make sure you underline the key points in every question so that you do not miss marks for what you know and you do not put down. I can only wish you luck now. Good luck. And as soon as you finish the test, get in touch. Let me know how you did. And once you get the result and you get that prediction, who do you think is the second person to know? There's somebody that you have to know before me, but who do you think the second person is? Yeah. Okay. So parents, if you're watching me for the first time and you have a child who is starting year 12 or indeed is going into year 13, I can assure you there is a major difference between year 11 chemistry and year 13 chemistry. Indeed, the gap between year 12 and year 11 is like this. Between year 11 and year 13, it's a very big gap. So if you want your child to secure admission into a prestigious university without going through clearance, and you want them to study the course of their dreams, prestigious courses that requires them to achieve at least an A in A-level chemistry, reach out to us. We will qualify the child, and we are bold enough to tell you if we can help your child. And if we can, we will map out a plan for the child. We do not believe in supporting students per hour. In other words, some parents call me and say, how much do you charge per hour? And I say, well, I do not charge per hour, because how long will it take for this child to move from a grade D, E, C to an A? So it's a program that focuses on results. So leave a comment below, or indeed phone us. All our contact details are on the group and also on the Brashan Chemistry page, and more importantly, on the website. The website has all the information. Thank you for listening. Have a great day. Bye for now.